Korean researchers have developed an artificial material that can cloak objects. This breakthrough could help boost the nation's military capability when implemented in stealth systems.
China has just unveiled a groundbreaking military invisibility suit that has not only surprised global defense experts, but also sent shockwaves through U.S. military circles.
It's like something out of Harry Potter, an invisibility cloak that makes people and objects disappear from view, able to hide in plain sight.
This groundbreaking technology, once imagined to only be science fiction, is now a reality, showing China's rapid advancements in military technologies. As the world grapples with the implications of such innovations, the U.S. and other nations are left wondering how this new development could potentially challenge the balance of military power and reshape the future of warfare. What does this mean for China's counterparts? Join us as we get into all the details. The military suit. Fiction and reality have meshed to incredible extents in the past decades, and it is no longer a surprise to see sci-fi-inspired inventions used in everyday life. The military field has been no exception, and is now on the peak of groundbreaking innovations that could change war-making to its core. One such development is China's recent strides toward a technological breakthrough that could bring invisibility. By developing a novel material capable of bending light in ways that make objects almost invisible to the human eye, this advancement could pave the way for numerous applications, especially in military and high-tech industries. What was once only myths may soon become part of our everyday world. Keep watching to find out more about the cloak. At the forefront of this research is the chimera metamaterial.
Materials that can interact with electromagnetic radiation based on their structure? That's so meta.
Named after the mythical creature, which blends attributes from 3 cold-blooded animals: the chameleon, glass frog, and bearded dragon. These creatures have evolved unique survival strategies that help them evade detection in nature. For instance, chameleons change their skin pigmentation to blend with their surroundings. Glass frogs are naturally transparent during slumber, and bearded dragons regulate their body temperatures, helping them blend into various thermal environments. By mimicking these natural abilities, Chinese scientists have created a material that can adapt to different terrains and spectral environments, making it highly versatile for camouflage. This material holds the potential to transform both military stealth technology and wildlife conservation efforts. This metamaterial works by manipulating electromagnetic waves. Unlike traditional materials, which reflect or absorb light in predictable ways, the chimera material alters the behavior of light and other electromagnetic waves. This bending of light allows it to cloak objects, making them disappear from radar, infrared, and even the naked eye under certain conditions. The implications of such technology are profound, with applications not only in military stealth but also in many other fields, such as surveillance and even healthcare. Metamaterials like chimera derive their unique properties not from their chemical composition, but from their structural arrangement. These materials contain repeated patterns, often on a microscopic or nanoscopic scale, which allow them to interact with electromagnetic waves in unconventional ways. This precise manipulation of waves enables invisibility across multiple spectra, from microwave to visible light. The concept of invisibility isn't entirely new.
A London company said they are looking to make science fiction reality. Check this out. A team of scientists and engineers created a fully functional invisibility shield.
Over the past decade, scientists worldwide have been working on various invisibility cloaks using similar principles of light manipulation. However, most of these earlier attempts have been limited in scope, often constrained to narrow wave bands or specific angles of view. The chimera metamaterial breaks through these limitations by offering flexibility across a broad range of frequencies, allowing it to adapt to ever-changing environments and provide invisibility under various conditions. For example, earlier invisibility cloaks could only work when viewed from certain angles, making them impractical for full camouflage. However, with the chimera metamaterial, the adaptability allows for a more robust cloaking effect, covering the object from multiple detection methods. This brings researchers a step closer to true invisibility, where objects can remain hidden regardless of environmental factors or detection methods. The Chimera metamaterial's military applications are among its most promising uses. In warfare, stealth technology provides a strategic advantage, allowing soldiers, vehicles, and aircraft to evade detection by radar, thermal imaging, and visual surveillance. Traditional camouflage techniques are only effective within limited ranges and environments. For example, radar-absorbing paint can help reduce an aircraft's visibility to radar, but it does nothing to conceal it from infrared or visual detection. On the other hand, the Chimera metamaterial could theoretically conceal an object from multiple detection methods simultaneously. Whether on the battlefield or during covert operations, soldiers wearing a cloak made of Chimera could become virtually invisible to the enemy, blending seamlessly into their surroundings. This capability would drastically reduce the risk of detection and increase the effectiveness of military operations, providing a significant tactical advantage. In addition to concealing personnel, the material could be applied to military vehicles, aircraft, and even naval vessels. This would provide a tactical edge in situations where stealth and surprise are critical, such as reconnaissance missions.
Now, China encircled Taiwan with fighter jets and warships as it launched large-scale military drills around the island. Beijing said the drills were aimed at sending a stern warning to separatist forces in Taiwan.
Ambushes and strategic attacks. The potential applications extend far beyond current camouflage technology, making this material a game-changer for future military engagements. In a world where technological superiority often dictates the outcome of conflicts, having such an advantage could reshape modern warfare as we know it. Other countries with this technology. China is not the only nation exploring invisibility technology. Both Russia and Ukraine have made significant strides in developing advanced camouflage suits to protect their soldiers from thermal imaging equipment, a vital component of modern battlefield surveillance. For instance, Russia's HyderX company recently unveiled a suit designed to manipulate the ambient temperature around the wearer, effectively rendering them nearly invisible to thermal cameras. Similarly, Ukraine has made notable advancements with its invisibility cloak, specifically engineered to shield soldiers from Russian thermal detection systems. Developed by the Ukrainian defense initiative Brave 1, this cloak functions by blocking infrared radiation, the heat signature that thermal imaging relies on to identify targets. Weighing only 2.5 kilograms, it is lightweight yet durable, designed to be fireproof and withstand harsh weather conditions. But despite its advanced capabilities, the cloak has limitations. It is only most effective when the wearer remains still or moves slowly. High-speed movements can increase body temperature rapidly, making it difficult for the material to conceal the wearer's heat signature entirely. Thus, it is a highly specialized tool, most effective in situations where stealth and minimal movement are required. In the US and Israel, significant investments have also been made in developing invisibility cloaks capable of concealing military assets from detection across multiple spectra. One player in this field is Hyperstealth Biotechnology, a Canadian company widely known for its innovative camouflage solutions. Hyperstealth gained attention for its development of quantum stealth.
We're trying to trick the brain into seeing things that aren't actually there. What's coming up down the road and very quickly is the Harry Potter cloak. You wouldn't see him at all.
A material designed to bend light around objects, effectively rendering them nearly invisible to the naked eye and thermal imaging devices. According to the company, this technology works by manipulating light reflection and reflection, allowing the material to create a cloak effect that can be applied to soldiers, vehicles, and other military assets. Reports suggest that the US military has been exploring partnerships with companies like Hyperstealth to integrate advanced stealth capabilities into their operations, making sure they maintain a competitive edge on the battlefield. However, China's recent developments with the Chimera metamaterial have raised concerns among military experts worldwide. If one country succeeds in developing a fully functional invisible cloak before others, it could shift the balance of power in global conflicts. However, China's recent developments with the Chimera metamaterial have raised concerns among military experts worldwide. If one country succeeds in developing a fully functional invisibility cover before others, it could shift the balance of power in global conflicts. But despite these advances by Chinese researchers, a perfect invisibility cloak has yet to emerge. Creating a material that can render objects completely invisible in all conditions remains an elusive goal. The Chimera metamaterial is an important step forward, but challenges and implications remain before it can be mass-produced or widely deployed. What implications could this new technology potentially pose? The implications of this new technology.
The fine people over at the Karlsruhe Institute of Technology in Germany have created a polymer that can make any object invisible to the sense of touch.
While the military is an obvious application for this technology, the Chimera metamaterial could have profound implications in other fields as well. In wildlife conservation, for example, researchers could use the material to observe animals in their natural habitats without disturbing them. By concealing cameras or drones with Chimera, conservationists could gather data on endangered species without human interference, which often alters animal behavior. This non-invasive observation technique could provide a wealth of information about ecosystems, helping scientists develop better conservation strategies. Additionally, the material's ability to bend light could have medical applications, such as improving imaging techniques or enabling more accurate diagnostic tools. As with any advanced technology, there are always causes for concern. The development of invisibility cloaks raises some ethical concerns. Although this invention can assist the day-to-day lives of ordinary citizens through observations of animals or searching for lost people, ethical problems begin to arise. Invisible technology does not have a foundation for its rules and regulations yet. Therefore, crimes similar to spying and stalking disturb citizens. In the wrong hands, this technology could be used for nefarious purposes, such as criminal activities or unauthorized surveillance. Though military personnel can use it to their advantage, in the long run, governments will need to establish regulations and safeguards to prevent the misuse of invisibility technology. Another challenge lies in the cost and scalability of the Chimera metamaterial. Producing enough of the material for widespread use could be expensive and time-consuming, especially since current manufacturing techniques are not yet capable of creating the super materials required for a fully functional invisibility cloak. However, with continued investment and research, it is likely that these obstacles will be overcome in the coming decades. Although a practical invisibility cloak may still be years away, the progress made by Chinese scientists is a significant step forward. As nations around the world race to develop this technology, the potential applications continue to expand, from military and scientific uses to consumer products and beyond. Whether it's for stealth operations, wildlife conservation, or medical advancements, this invisibility technology has the potential to transform numerous industries. As researchers continue to refine this dangerous yet fascinating invention, the future of invisibility technology holds exciting new possibilities, and the boundaries between science and science fiction are becoming increasingly blurred.
The sun has always been a part of our lives, and we cannot deny it. We all know that the beautiful light of the day comes from the sun and holds immense importance to mankind and plays a vital role in sustaining life on Earth. Let us start with the fact that the sun is a primary energy source for our planet. Through a process called nuclear fusion, it continuously emits vast amounts of light and heat energy, which we maximize for different purposes. This solar energy powers the Earth's climate systems, drives weather patterns, and supports the growth of plants through photosynthesis. Sunlight is essential for photosynthesis, the process by which green plants, algae, and some bacteria convert light energy into chemical energy. This enables them to produce oxygen and generate food from sugars and carbohydrates. The oxygen released during photosynthesis is crucial for the respiration of most organisms on Earth, including humans. So, if we need oxygen, then we need the sun. Besides that, sunlight is necessary for agricultural productivity, as crops require sunlight for photosynthesis, which promotes their growth and development. Sunlight also provides the energy plants need to produce fruits, vegetables, grains, and other food sources. Thus, the sun indirectly supports our global food supply. That's without mentioning the vitamins which the sun gives. Exposure to sunlight enables the human body to produce vitamin D. It happens that when our skin is exposed to ultraviolet B, UVB radiation from the sun, a chemical reaction occurs, resulting in the synthesis of vitamin D. This vitamin plays a crucial role in maintaining healthy bones and teeth and supporting the proper functioning of the immune system. Like that isn't enough, the sun's energy also drives the circulation of air and ocean currents, shaping the Earth's climate. It influences temperature patterns, wind systems, and precipitation levels. Variations in solar radiation can impact global climate change and long-term weather patterns, underscoring the sun's role in climate regulation. And whether you know it or not, sunlight significantly impacts our mood and overall well-being. Exposure to sunlight triggers the release of serotonin, a neurotransmitter associated with happiness and well-being. It also helps regulate our circadian rhythm, which governs our sleep-wake cycles and influences various physiological processes. Here's what we're driving at. The sun provides an abundant and renewable energy source through solar power technologies that harness sunlight and convert it into electricity or heat. Here, solar panels capture the sun's energy and enable us to generate clean, sustainable electricity, reducing our reliance on fossil fuels and mitigating climate change. While it's become widely known that there's a general environmental degradation that's come about through the use of fossil fuels and toxic substances to generate energy, solar energy points to a way out. Today, the world is growing past the pursuit of energy from fossil fuels with the need to transition to clean energy. As a result of this, more energy is demanded from the sun. But in this demand, China has gone further than expected. Right on Earth, China has embarked on a journey to reproduce the sun on Earth by producing an artificial sun that'll be 5 times hotter than the original sun and would dwell within the confinements of Earth. This is the beginning of a massive project called EAST, an artificial sun that would eventually cost China about $1 trillion. Now, why don't we talk about the mind-blowing invention of China's artificial sun, known as EAST. China's artificial sun, also known as the Experimental Advanced Superconducting Tokamak, EAST, is a nuclear fusion reactor under development since 2006. EAST is a major scientific project to develop nuclear fusion as a potential source of clean and abundant energy. In this project, China is not alone, but actively collaborates with other countries and international fusion research projects, with the primary goal of EAST being to explore and develop the technologies required for practical nuclear fission. Nuclear fission refers to the process that powers the sun and stars, where hydrogen atoms combine to form helium, releasing vast amounts of energy. Scientists aim to replicate this process on Earth with EAST to generate sustainable energy. Thus, the project was kickstarted at the Institute of Plasma Physics, part of the Chinese Academy of Sciences in Hefei, Anhui Province, China. Now, you must know that the sun inspired everything about EAST. This simply means that the artificial sun is not made of anything different from the original sun. So, to understand how EAST works, we must look to the sun. The sun, is a star located at the center of our solar system. It's primarily composed of hydrogen, about 74% by mass, and helium, about 24% by mass. The remaining 2% consists of trace amounts of heavier elements, such as oxygen, carbon, neon, and iron. Its energy is generated through a process called nuclear fission. Nuclear fission happens in its core when extreme pressure and temperature cause hydrogen nuclei to collide and fuse together, forming helium nuclei. The fusion process releases an enormous amount of energy in the form of light and heat. Specifically, 4 hydrogen nuclei combine to form 1 helium nucleus, releasing 2 positrons, 2 neutrinos, and an enormous amount of energy. The sun's core is where the fusion reactions occur, accounting for about 25% of the sun's radius. Surrounding the core is the radiative zone, where the energy produced in the core is transported outward by photons. This zone is characterized by a transfer of energy through the absorption and re-emission of photons by ionized atoms. Beyond the radiative zone is the convective zone. In this region, the energy is carried by the movement of plasma, a hot ionized gas. Large convection currents transport the energy from the interior of the Sun to the surface in the form of rising and sinking plasma. The Sun's outermost layer is the solar atmosphere, which consists of three main parts: the photosphere, the chromosphere, and the corona. The photosphere is the visible surface of the Sun, which emits the light that we see and has a temperature of about 5,500 degrees Celsius. Above the photosphere is the chromosphere, a region of higher temperature and lower density, which is visible during solar eclipses as a reddish ring around the Sun. The outermost layer, the corona, extends millions of kilometers into space and has a much higher temperature than the layers below, reaching several million degrees Celsius. Very importantly, the Sun's energy output is electromagnetic, including visible light, ultraviolet, UV, and infrared (IR) radiation. This energy is crucial for sustaining life on Earth and driving various atmospheric and climatic processes, while solar power itself is sustained by the continuous fusion of hydrogen nuclei into helium in the Sun's core. This fusion process converts a small fraction of the Sun's mass into energy, following Einstein's famous equation E=mc². The enormous gravitational pressure exerted by the Sun's mass keeps it stable, balancing the inward gravitational force with the outward force generated by the energy released through fusion. How are the operations in the actual Sun mirrored in China's artificial Sun, EAST? As earlier stated, EAST follows the methods and patterns of the Sun. It takes the tokamak design, one of the most promising approaches for achieving controlled fusion like the Sun. The tokamak consists of a torus-shaped vacuum chamber where plasma is confined and heated to extremely high temperatures. EAST uses powerful magnetic fields to confine and control the plasma. Superconducting magnets generate a toroidal donut-shaped magnetic field that contains the hot plasma, preventing it from contacting the chamber's walls. Several heating methods are employed in EAST to achieve the required plasma temperature. These include neutral beam injection, radio frequency, and electric cyclotron resonance heating. These methods provide the energy needed to reach the extreme temperatures necessary for nuclear fusion. The primary components of EAST include the vacuum vessel, which houses the plasma, which is typically made of a high-strength steel alloy. The superconducting magnets are constructed using advanced superconducting materials, such as niobium titanium or niobium tin alloys, which allow for efficient generation of strong magnetic fields. Let's talk about safety. How secure is the groundbreaking invention of China's artificial Sun? Is the ambitious country embarking on a path toward Earth's eventual demise? Rest assured that's not the case, as the cutting-edge tokamak chamber has been ingeniously engineered to prioritize safety above all else. This is seen in the meticulous design of the tokamak, ensuring that it maintains a mere fraction of hydrogen fuel, less than 1/10 of a gram at any given moment. This ingenious setup guarantees that any disruptions during a pulse reaction are swiftly extinguished, allowing for rapid cooling and rendering a nuclear explosion implausible. As if that weren't enough, scientists are going above and beyond, implementing various preventive measures to enhance safety within the fusion power plant. Consequently, even in the unlikely event of a cataclysmic breach in the tokamak, the resulting radioactive activity outside the plant's enclosure would be negligible, posing a minimal risk. How successful has the artificial Sun come to be? So far, EAST has achieved several significant milestones in fusion research. In 2018, it set a new world record by achieving a plasma temperature of 100 million degrees Celsius for over 10 seconds. It's also made advancements in long pulse operation and plasma stability. Ever since then, there's been a constant improvement in the project. In May 2021, EAST reached a 120 million degree electron temperature milestone for 101 seconds. Another quickly followed this achievement on April 12, 2023, when East achieved the world's first 403-second steady-state H-mode plasma. These record-breaking successes are a testament to the progress that China's making in the field of nuclear fusion research. While East is a key part of China's effort to develop a fusion power plant, it's a stepping stone to a bigger project, the International Thermonuclear Experimental Reactor, ITER. ITER is an international nuclear fusion research and engineering mega-project aimed at creating energy through a fusion process similar to the Sun. It's an improvement on East and is being carried out by 7 member states: China, the European Union represented by Euratom, India, Japan, Korea, Russia, and the United States. It's located in the Cararache Research Center in southeastern France. Construction began in 2013 for this mega project and is expected to be completed in 2025. Once completed, ITER will be the world's largest and most powerful fusion device. The primary objective of ITER is to produce a fusion reaction that generates more energy than is used to heat the plasma. This is known as a burning plasma. ITER aims to be a mind-blowing project, and if it's successful in achieving a burning plasma, it'll be a major milestone in the development of fusion power, creating new paths for the world of energy. ITER will also test the availability and integration of technologies essential for a fusion reactor, such as superconducting magnets, remote maintenance, and systems to exhaust power from the plasma. The results of these tests will be used to design and build future fusion power plants. Fusion is a promising long-term option for a sustainable, non-carbon emitting global energy supply. If ITER is successful, it could pave the way for the commercialization of fusion power in the coming decades. In appearance, the ITER tokamak will be 30 meters in diameter and 12 meters high. It'll contain 18,000 tons of superconducting magnets, which will confine the plasma. The ITER tokamak will require 500 megawatts of electricity to operate. The fusion reaction will produce 500 megawatts of power, which will be used to heat the plasma and operate the various tokamak systems. ITER is expected to produce a burning plasma for up to 500 seconds. This earned its spot as a major milestone in developing fusion power. With this ambition comes a high price, however, as the cost of the ITER project is estimated to be 18 billion euros. To ease the financial burden, the 7 member states contribute to the project's cost in proportion to their gross domestic product. ITER is expected to be completed in 2025. Once completed, it'll be the world's largest and most powerful fusion device. ITER is a major international collaboration that's a key step in developing fusion power. If ITER is successful, it could pave the way for the commercialization of fusion power in the coming decades. Overall, a transition to clean energy will be a game changer for the world on the move of China to achieve an earthly sun that promises limitless energy. This is backed up by scientists finding that fusion fuel is everywhere. It's been discovered that the other route, which is required for fusion energy, can be extracted from seawater and breed tritium from lithium. In fact, just 1 little liter of seawater contains enough fusion material to produce as much energy as 300 liters of gasoline. That's like having unlimited energy at our fingertips. The advent of tech has been highly beneficial to mankind since time immemorial. Ranging from gigantic undertakings to mini inventions, it all points to a progressive end that not even scientists can determine. Today, China seems dissatisfied with the current levels of energy gotten from the sun and seeks more. Thus, encouraged by years of research, experiments, and success, China is set to take gigantic steps on a groundbreaking invention that will forever change the world. And it involves creating an artificial sun that'll be 5 times hotter than the original sun. This is no small task because after all said and done, its cost would run over $1 billion. This is not a feat for a weak nation, and thankfully, China's not weak. But let's look at the project more closely. How easy is the undertaking, and what does it entail? The Sun has long been a very important part of our solar system, being a source of energy and wonder. Not only that, but it's also a complex part of scientific studies and research as we find more ways to harness its resources. Today, China's no longer trying to understand the power of the Sun, but is in a bid to replicate it. China's even going a step further in an attempt to replicate the Sun. But to replicate the Sun, one must understand how it works, right? So, what stuff is the Sun made of? The Sun is a star located at the center of our solar system. It's a nearly perfect sphere of hot plasma, primarily composed of hydrogen and helium, along with trace amounts of other elements. In its deeper composition and characteristics, the Sun's core, which is the central region where nuclear fusion occurs, is extremely hot and dense. The intense pressure and temperature at the core enable the fusion of hydrogen nuclei, protons, into helium nuclei, releasing an enormous amount of energy in the process. This process, known as thermonuclear fusion, is what powers the Sun and produces the light and heat we receive on Earth. About 74% of the Sun's mass is hydrogen, which is the lightest and most abundant element in the universe. Helium makes up roughly 24% of the Sun's mass. These two elements dominate the Sun's composition, accounting for around 98% of its total mass. The remaining 2% consists of heavier elements, including oxygen, carbon, neon, nitrogen, and iron, among others. The Sun has several distinct layers. Surrounding the core is the radiative zone, where energy generated by nuclear fusion is transported outward through radiation. Beyond the radiative zone lies the convective zone, where energy is transported through the movement of plasma, akin to boiling water. Above the convective zone we have the photosphere, which is the visible surface of the Sun. It emits the sunlight we see and has a temperature of around 5,500 degrees Celsius. The photosphere is marked by dark spots called sunspots, which are cooler regions caused by intense magnetic activity. Beyond the photosphere, we encounter the chromosphere, a layer of the Sun's atmosphere. The chromosphere is only visible during a total solar eclipse or with specialized telescopes. Above the chromosphere, the Sun's outermost layer is the corona, an extremely hot and tenuous region that extends millions of kilometers into space. The corona is also visible during a total solar eclipse as a faint pearly white halo around the darkened Sun. Here, the surface of the Sun produces an energy of 63 million watts per square meter, but then it travels over a distance of 150 million kilometers, which is 93 million miles, to get to the Earth. This journey alone diminishes the amount of energy that gets to the Earth's surface, and by the time it reaches the Earth, it becomes 1,370 watts in the atmosphere, and this is at a point directly facing the Sun. The Sun's energy output is essential for sustaining life on Earth and drives our planet's climate, weather systems, and the photosynthesis process in plants. Additionally, the Sun's gravitational pull keeps the planets in our solar system in their respective orbits. It's worth noting that the Sun is just one of countless stars in the universe, and its composition and characteristics are typical of main sequence stars like it. But in our solar system, the Sun is the main thing. It makes up most of our solar system, covering about 99.8% of the solar system. Hence, the Sun could be called the largest thing in our solar system, as the other planets find their spots in the remaining 0.2% of space. In the end, the Sun has a diameter that's over 109 times the size of Earth's diameter. The hotness and energy of the Sun are ones that cannot be matched until you're able to explode 100 billion tons of dynamite every second. Inner Milky Way, our star, also known as stellar, belongs to a particular family where it's relatively one of the youngest. It's part of the generation of stars which are widely called the population 1 star. These stars are a group of stars that contain elements heavier than helium. Indeed, we know that Stellar is quite young, being about 4.5 billion years old, yet scientists claim that we still have a long way to go with her. as she's expected to have enough fuel to keep her up for another 5 billion years. Solar energy comes from nuclear fusion. It creates a helium atom process that's known as the proton-proton chain reaction and produces energy at the end. The Sun fuses about 620 million metric tons of hydrogen every single second due to its temperature. This leads to a release of 2 positrons, which are released alongside 2 neutrinos. They're converted into 2 protons and 2 neutrons, which are then converted into energy. Nuclear fusion is a process in which 2 or more atomic nuclei come together to form a single, more massive nucleus. This process releases a tremendous amount of energy. Fusion occurs naturally in stars where hydrogen nuclei combine to form helium. Now, scientists are working on developing practical methods to achieve controlled nuclear fusion. The most common approach involves heating and compressing hydrogen isotopes, such as deuterium and tritium, to extremely high temperatures and pressures. These conditions are necessary to overcome the repulsive forces between positively charged atomic nuclei. When the hydrogen isotopes reach sufficient energy levels, their nuclei can overcome the electrostatic repulsion and come close enough for the strong nuclear force to bind them together. This results in the formation of a new nucleus, releasing a large amount of energy in the process. The released energy is several times greater than what's obtained from traditional nuclear fission reactions, as used in nuclear power plants. Thankfully, scientists have discovered the fact that fusion fuel is abundant. Deuterium can be extracted from seawater, and tritium can be bred from lithium. It's said that just 1 liter of seawater has enough fusion material to produce energy equivalent to that of 300 liters of gasoline. This is unlimited energy. One of the main challenges in achieving controlled nuclear fusion is creating and sustaining the necessary conditions, as they require immense amounts of energy. And this is where yeast comes in. It is designed to confine and control the high-temperature plasma where fusion reactions occur, and it's what will pave the way to China achieving its dreams. So let's talk about the yeast. Now, China's intentions to create a sun that's superheated is followed through by creating a plasma globe that's 5 times hotter than the sun, and it'll be done through a reactor known as the Experimental Advanced Superconducting Tokamak, EAST. EAST is also known as the Chinese Artificial Sun. EAST is a nuclear fusion research device located at the Hefei Institutes of Physical Science in China. The goal of the project is to develop and demonstrate the feasibility of nuclear fusion as a clean and virtually limitless energy source. EAST utilizes a magnetic confinement system known as a tokamak to create the conditions necessary for nuclear fusion. It consists of a torus-shaped vacuum chamber where a superheated plasma of hydrogen isotopes is confined and controlled using intense magnetic fields. The toroidal shape allows for the generation of magnetic fields that confine and control the superheated plasma within the device. The aim is to achieve a state of plasma where the isotopes are heated to extremely high temperatures and fusion reactions can occur. China's artificial sun has made significant progress over the years. In 2018, researchers at EAST achieved a major milestone by reaching a plasma temperature of over 100 million degrees Celsius, which is several times hotter than the core of the sun. This breakthrough allowed them to sustain plasma for a record-breaking 101.2 seconds. But why exactly has China undertaken this task? The research conducted at EAST contributes to the global pursuit of practical fusion energy, which could provide a clean and abundant source of power without the drawbacks associated with conventional nuclear fission reactors, such as radioactive waste and the risk of meltdowns. In the pursuit of this project, only one thing is in mind, and it's a desire to produce a clean form of energy that has no fossil fuel, no waste material, and not being a precursor to environmental disasters. Over the years, man's been in a constant battle to choose between saving the environment or pursuing toxic energy. This is now on the brink of being over. But how safe is the new invention of the artificial sun going to be? Are we on the road to self-destruction? Clearly, the chamber that's in the modern tokamak has been designed for safety. This is proven in the fact that it contains less than 1/10 of a gram of hydrogen fuel at every single time, which means that any disruption that may occur during a pulse reaction will immediately be quenched and cooled down, leading to no nuclear explosion because it's not possible. Scientists are also undertaking more precautionary measures for the project for additional safety in the fusion power plant. This would mean that any cataclysmic breach in the tokamak would only create a very low level of radioactive activity outside of the plant's enclosure. The next big thing. However, East is the starting point, as it serves as a valuable platform for research and experimentation, helping scientists explore the possibilities and challenges associated with harnessing fusion energy. It is, in fact, just the start of a bigger project of fusion known as the ITER, or the International Experimental Reactor, which is now being built by a combination of countries that include France, the EU, the UK, China, India, the US, and others. Here, they're employing all that's been learned from East to make it a better version of a fusion plant. ITER would contain the most powerful magnetic field in order to make it capable of producing a magnetic field about 280,000 times as strong as that of the Earth. Merely putting 50 megawatts of energy into the system to start up the reactor would produce about 500 megawatts. Again, the internal volume of plasma that ITER is capable of holding is a pleasant shock to scientists. ITER would be able to hold a plasma volume of about 830 cubic meters, which is several multiples of the previous maximum volume of tokamaks, which only operated about 100 cubic meters. ITER's new plasma volume will enable it to produce a burning plasma for the first time. This has been China's dream for 50 years now, and there's so much excitement as new holds that this fusion reactor will be launched in 2025. We've come to the end of today's video. Thanks for watching till the end. What are your opinions about the artificial sun move? Let us know your thoughts in the comment section below. And if you enjoyed this video, be sure to like, share, and subscribe for more.